All right, good afternoon and welcome to today's Richard M. Karp Distinguished Lecture. I'm Sandy Arani. I am the Associate Director of the Simons Institute for the Theory of Computing. And for those of you who are not familiar with the Simons Institute, we are the leading international venue of collaborative research in theoretical computer science. Simons was established in 2012 with a very generous grant from the Simons Foundation. And the Institute brings together the world's leading researchers in theoretical computer science and related fields, as well as the next generation of outstanding young scholars in the fellows programs. So the primary aim of the organization is to explore the use of algorithmic thinking in science and engineering, and also to study the laws of computing itself. And before I get started, I just wanted to sort of go over how to ask a question in today's talk. Some of you are physically present here at Calvin's Lab, and others will be joining through Zoom. So if you're in the room, you can just raise your hand and ask a question. Those listening over Zoom can pose a question through the Q&A, and I'll be monitoring that throughout the talk. So we established the Richard M. Karp Distinguished Lecture Series to celebrate the role of Simons Institute Foundational Director, Dick Karp, and to celebrate Dick's many contributions to the field of theoretical computer science, formulating central problems, and his stunning array of results in computational complexity and algorithms. This series features visionary leaders in theoretical computer science and is geared towards a general scientific audience. And so we're grateful to the many contributors to the Richard M. Karp Fund who have made this series possible. So I'm really excited today to welcome Nicole Immorlica to give the talk. And Nicole is a senior principal researcher at Microsoft Research New England, where she leads the economics and computational group. She's also the chair of SIG-Econ, the ACM Special Interest Group on Economics. And Nicole received her Bachelor of Science, Masters of Engineering, and PhD in Theoretical Computer Science from MIT, and later joined Microsoft New England in 2012. Nicole's research interest is in the design and operation of socio-technical systems. So she uses tools and modeling concepts from theoretical computer science and economics with the goal of explaining, predicting, and shaping behavioral patterns in online and offline systems, markets, and games. Nicole is best known for her work on social networks, matching markets, and mechanism design. She's also the recipient of a number of fellowships and awards, including the Sloan Fellowship, the Microsoft Faculty Fellowship, and the NSF Career Award. So her talk today is entitled Birds of a Feather Flock Together: How Homophily Leads to Segregation, Inequality, and Inefficiency, and What We Can Do About It. So please join me in welcoming Nicole.
Great, thanks for the introduction. So what I'd like to talk to you about today is homophily. And homophily is this idea that we all tend to seek out relationships with people that are similar to us, right? So you look for friends with which you share common traits and characteristics. And I think this is a very intuitive idea if you look around at your own friend groups, but it's also well documented in data. So this here is a graph. You can find this graph in the wonderful popular science book, The Human Network, by one of my co-authors, Matt Jackson. And what this graph is demonstrating is the social network of a high school. And each node here is a student. There is an edge between two students if they have engaged in more than 3 activities together. And the nodes are colored according to the race of the student. So the blue nodes here are Black students, the yellow nodes are white students, and then there's spattering of other races intertwined in here as well. And what you can see visually here is that the Black students tend to have more Black friends than white friends, and the white students tend to have more white friends than Black friends. That is, there's a natural tendency towards homophily in this network. The network kind of segregates in a sense. And so why should we care about this phenomenon? I'm gonna sort of take this phenomenon as a fact throughout this talk and try to think about how it impacts. This is a very local phenomenon, right? It's like my personal choices about who to befriend. I want to see how that impacts global societal level outcomes. And the first half of the talk, I will discuss the impact of segregation on the impact of homophily on segregation in geographical networks, or in housing markets, if you like. So this is a graph of Boston, which is where I'm from. And here, this is based on the 2010 census data. There's a dot colored for each in each geographical area according to the race of the individual that lives there. So blue is white, green is black, and so on. What you'll see is that the city is largely segregated. There's areas where there's a lot of white residents. There's areas that are mostly Black and Hispanic. There's a Chinatown, which is predominantly red. And so, and yet there is some amount of integration as well in certain neighborhoods. And so the question is, does homophily, these sort of very local preferences about who your individual friends are, lead to this kind of citywide segregation? And so we'll discuss that in the first half of the talk. And then in the second half of the talk, I want to discuss the impact of homophily on labor markets, in particular, the inequality in labor markets and how it perpetuates over time in the form of immobility. It will also see that it surprisingly perhaps has implications for the productivity of the economy as well. So even if you don't care about equity from a outcome perspective, if you're a utilitarian and you care about welfare, you should also care about this impact. And so here's again some data just to demonstrate that this phenomenon exists in society. There's of course many, many reasons for this. But we'll see that homophily also can be one driver in these sorts of outcomes. And so this graph shows you the disparity in employment rates between white and Black men and how that persists over time. You can find many similar plots in the US Bureau of Labor Statistics. So let me jump right into talking to you about homophily and its impact on housing markets. This literature was really initiated in the 60s by the Nobel Prize winning economist Thomas Schelling, who wanted to study this idea that I've been discussing with you, that these very micro motives, as he called them, these individual preferences for my very local neighborhood could have macro effects. And Schelling focused primarily on lattices, which you could think of as being rough approximations to the geographies we see in cities. He studied a one-dimensional lattice and a two-dimensional lattice, as I've drawn on the slide here. So each point on this lattice is, you can think of it as being a house. And in each house lives a person who is one of two types. And throughout this talk, I'll be discussing populations with two types of agents represented by green triangles and blue circles. So initially, maybe the city is pretty integrated. So every house is occupied by a type with equal probability. But nonetheless, people have these sort of micro motives. They have a preference to be in a neighborhood. They want their local neighborhood to look similar to them, to have a lot of people of their type. So the neighborhood of an individual is defined to be all the houses that are within some distance of that individual. So we'll keep W as the parameter for the size of the neighborhood. And then the node is going to decide whether they're happy or not based on the composition of this neighborhood. So here we see that the center node, this center green triangle in the slide, has a neighborhood represented by that blue diamond. And the node will look around at the local neighborhood and realize, well, there's 5 triangles and 8 circles, and then decide, is being in a 5/8 minority sufficient for me to be happy or not? And so that's going to depend on this, what we call tolerance parameter tau. Tau equals a half would mean that I just don't want to be a minority. I'm happy so long as I'm not a minority. Tau less than a half means you're okay being a minority so long as it's not smaller than a tau minority. And then what's going to happen in the dynamics is that nodes that are unhappy are going to move. And there's two sort of dynamics by which moving might happen. You could imagine if you think of a city as a closed system, then in order for you to move, you need somebody else to move. So you need to like find someone to swap houses with. This is the swapping dynamic. We talked about this in the boot camp in the context of one-dimensional shelling dynamics and realized that it's quite close to the flipping dynamic. Today, I'll focus on the flipping dynamic, which you could think of as more of an open city kind of dynamic, where if you're unhappy as a minority in Boston, you're going to move to New York, and somebody else from the outside world will move to Boston. And so this is represented by just flipping the color of the node if they're unhappy. But at the high level, what's happening here is that unhappy nodes are going to change color. And the question is whether these micro motives, the fact that I don't want to be too small of a minority in my local neighborhood, can have macro impacts. Just to summarize the sort of main parameters, but you don't really need to remember many symbols. I'm going to try and do most of this talk without much math. We have the neighborhood size, W, that's how wide of a neighborhood I'm sensitive to, right? Like who I consider to be a neighbor. It's anyone living within distance W of me. We have the size of the society, that's how many people live in the city, N. And we have a tolerance parameter, tau, how willing I am to be a minority. And so let's sort of investigate how these dynamics play out in a network. So here I have a simulation. This is on a society of 750 squared people, and the neighborhoods are of size 5, and the tolerance parameter is 0.5. So this is the situation in which I simply don't want to be a minority at all. I'm intolerant of being in a minority. I'm happy to have neighbors of the other color, right? But I don't want to be a minority. So what's going to happen as we run the dynamic? Okay, so I'm playing the movie now, and you can see that people are moving around in this square, trying to find, they're flipping colors to try and become happy. And over time, you start to see these shapes emerge, these blue and red shapes, but they're kind of like noodle-like and intertwined in funny patterns, right? And so this is a simulation, but the question that I want to explore in the first half of this talk is whether we can prove anything quantitative about the patterns that arise from this type of dynamic. So what sort of quantitative things might I hope to say? To remind you, this is the fully tolerant case. Nobody's going to move, right? So we just stay with whatever the initial configuration was, which was complete integration. And for this sort of critical tolerance 0.5, we're going to end up with some picture which maybe looks like that. And how am I going to explain that the left is more segregated than the right? The measure of segregation that I choose to study is the radius of the largest monochromatic region containing a random node. Okay, so you might be in, if you're, you have a very big ball around you that's all blue as a blue node, then that's a very segregated neighborhood. If you have a very small region, like in this picture, then it's a very integrated society. And what we saw, so remember, I just showed you a bunch of simulations on a 2D lattice. You can also talk about all of this on a 1D lattice. And what we saw in the boot camp was that for the one-dimensional lattice at this critical threshold of 1/2, there's actually not all that much segregation in the society, right? So we argued that the segregated neighborhoods have size something like, I showed you order W squared, but order W is known. Actually, that order W is a follow-up paper. But the point here being that it's something polynomial in W. So it's small. It's like on the order of neighborhood to neighborhood. It's a very nice integrated city where you have little ethnic enclaves. You have your Chinatown and your Little Italy and so on, right? So that's going to happen with this critical tolerance of 1/2. And it's interesting to think about why. In the boot camp, we explored the proof of this fact and saw that the reason that you're getting these kinds of monochromatic neighborhoods that are well distributed throughout the city is because the individuals are, initially almost everybody was unhappy and everybody wanted to move around. And so neighborhoods with a slight imbalance are going to very quickly become monochromatic, and then they become immune to immigration from the outside. And in particular, as soon as you get a length W monochromatic neighborhood, you're completely stable with respect to the dynamics. And since this is happening very frequently all over the place, you get a lot of these order W length neighborhoods. So that's what we saw about the critical threshold last week. But you might, and many of you asked me, what happens if we change this tolerance parameter? What if I insist on being a majority? Or what if I don't care at all about my neighborhood? So can we describe the pattern of segregation we get as we perturb, as we range across all tolerance parameters in society? And so this follow-up paper studied this question, showing, and there's the region of when people insist on being in a majority, and there the dynamics are a little bit funny, but for the definition they chose, you get total segregation. I'm going to not focus on that at all. And for small enough tolerance, so like when I don't care at all about my neighborhood, or I'm happy being a very tiny minority, you can imagine that not very many people are going to move. And so you should expect there to be a very small amount of segregation in the society. And what was very interesting is that there's this sort of threshold around a third, which says that if there are more than a third of the people, like if I insist on being I'm happy to be a minority, but I don't want to be too small a minority. I need like 0.35 people to be similar to me. Then what happens is you get worse results. You get exponential and W segregation. So we started, when people are super tolerant, we get a lot of integration. When people are happy to just not be a minority, we get integration. But when people are just a little bit tolerant, we get exponential segregation. And in fact, this curve is decreasing as you get towards 1/2. So if you think as a planner about maybe trying to get people a little bit more tolerant, if you can only move this tau by a little bit, just go a little bit this way, you actually get worse segregation as a result. So what I'd like to do today is tell you about that result in the 2D setting. So this is a follow-up paper with Bobby Kleinberg, Brendan Lucier, and Morteza Sadimoghadam. And so in this paper, we wanted to study these dynamics in a 2-dimensional lattice. And this is, I think, a more challenging mathematical problem than the 1-dimensional lattice, because these sorts of stable structures that we explored in the 1-dimensional case, if you happen to come to my boot camp lecture, are harder to define in the 2-dimensional case. So these firewalls I had been talking about are harder to define in the 2-dimensional setting. And so we had to leverage different techniques. And in fact, if you're looking for open questions to work on, nobody's been able to solve the case of tau equal to 1/2 for the 2-dimensional lattice. But what I'm going to tell you about is the subcritical tolerance, tau slightly less than 1/2. And what we're going to see is, as in the 1D case, this 2D subcritical tolerance regime gives you exponential segregation. And the rationale, the reason I'm interested in this, and I'll emphasize this again at the end, is I think by looking at the theoretical mechanism by which this happens, we can start to devise policies to address it. And so it's important to understand how the outcome is achieved in order to try and reverse it. And the sort of high level idea, I'll delve into the details a tiny bit, but the high level idea is that the way this happens is that, initially everybody's in a almost balanced neighborhood. And so almost everybody's fine with that, right? Because you're happy to be a minority so long as it's not too small of a minority. So by law of large numbers, your neighborhood's going to be fairly mixed and you're going to be fairly happy. But there's going to be rare cases where the segregation of your neighborhood is like a standard deviation away from what you expect. And in those rare cases, the minority is very unhappy and they're going to move out. And this is going to create a wave of immigration that's just going to wash over all those complacent people. And the only thing that can stop this wave of immigration is a wave of immigration of the opposite color. But since the origins of these waves are exponentially far apart, you're going to get exponential segregation. So let me go through that in a little bit more pictorial or like a little bit more detail on the slides to emphasize this point. This is just to start a simulation of what happens in this subcritical regime. So this is a simulation for tau equals 0.36. And you can see these are different snapshots in time. You can see that it starts out, well, it starts out integrated, but very early on, you start getting bubbles of different colors. And these bubbles just kind of grow and grow and grow until in the converged state, you get a lot of segregation. So the specific theorem, I'm not going to use any math in this talk, so I'm not going to prove these exact form of this segregation to you, but the theorem that we were able to state was that you're going to end up with segregation that's exponential in the neighborhood size, so long as the tolerance is sufficiently close to 1/2, but less than 1/2. Okay, so let me give you a very high level rationale for how this proof works, which is basically, I already told you in the initial slide, but I'll repeat with a slightly more detail.
So now it's the opposite. That's when the epsilon gets smaller, you seem to be positive before that. If you get a little bit more tolerant, then it's the same direction.
Yeah, so Christian is pointing out that as you get more tolerant, that is epsilon gets smaller, then your segregation is getting worse, so long as you're less than 1/2. So here's a rationale for it in pictures. We have in the beginning, as I said, most neighborhoods are pretty mixed. That is, most neighborhoods look like this. They're about half circle, half triangle. As time, however, there are also in the beginning a few neighborhoods that are very segregated just because of the initial conditions, right? So you get a few neighborhoods that look like this. They're almost monochromatic. And in the what I'll call complacent neighborhoods, the ones that are pretty mixed, everybody's fine. You know, like I might be a minority, but that's okay. Everyone's fine in the complacent neighborhoods. In the agitated neighborhoods, this green triangles, the minority type, are very unhappy and they really want to leave. And so they're going to leave. And what you should be thinking about is what happens when an agitated neighborhood abuts a complacent one. What's going to happen to the happiness of all these people on the boundary? And so a back of the envelope calculation, let's focus in on a minority type on the boundary. It's somebody who's a minority according to the invading agitated neighborhood. This guy is going to have, well, in the northeast, 100% or nearly 100% of the neighbors are going to be of the opposite type, right? And in the southwest, well, this neighborhood is close to uniformly random, so 20, half of these guys are going to be of the same type. And so when you add these up, you see that that guy has 75% of their neighbors of the opposite type. So this person, because we said the tolerance parameter was 0.36, this person is unhappy. And so this back of the envelope calculation should start to make you think that maybe somewhere around a quarter, there might be some kind of like, certainly if the tolerance was that I'm happy to be in a quarter minority, then maybe these things wouldn't take over, right? And if I'm somewhere closer, then these things are going to invade. Okay, so fine. So these monochromatic neighborhoods are invading, but that doesn't yet prove the result that the monochromatic neighborhoods grow exponentially large, because there could be another invading monochromatic neighborhood of the opposite type. And when two agitated things come up, when two waves of immigration hit, they're gonna stop, right? So we have to worry about that. And so all of the mathematical effort in the proof goes into showing that these things, because they're exponentially far apart, for any random node, we can draw an exponentially big circle around it. And in this inner circle, there will be exactly one monochromatic neighborhood or like area that's in the initial configuration very close to monochromatic, and no others. And then there's a buffer zone. So in the ring there's a buffer zone where everybody's complacent. And as a result, this guy is going to grow and will be buffered from invaders from the outside by this ring. And so it'll have sufficient time to overtake the region that includes the star. So that's a high level explanation of the proof of this result. If you want details, I'll refer you to the paper, as this is a high level lecture, so I'm not going to get into the math in particular. But let me recap here, which is that what have we learned from exploring this setting? We've learned that, okay, weak preferences for homophily, which we take as a fact that exists in this world, can cause drastic geographical segregation in housing markets. And that these, so that's the mathematical fact that we proved. And why do I think that's interesting? Because I believe that by understanding the theoretical groundings of societal facts like that, it will give us an idea about the mechanism that causes it. And understanding this mechanism is important to developing policies that address it. And so in this case, what we learned was that the mechanism that happens here, the reason that these local preferences have these global impacts, is because we get these homogeneous neighborhoods that are infiltrating the integrated ones, creating waves of immigration. And so this naturally points to potential policies to address it. For example, you could consider subsidizing houses in integrated neighborhoods. So like maybe we could just pay people to stay put. And these would just kind of form barriers that would resist the wave of immigration of the segregated neighborhood. So I put a question mark here because this is not something that I've analyzed. And so I think this is another interesting direction for future research, thinking about policies that create integrated cities. And one idea here is subsidized housing. Another idea is sort of maybe natural geographical barriers in cities might also stop these waves of immigration. But the high level point here is that because we now know this mechanism, we can start to think about ways to kill it, right? So that's what I wanted to tell you about homophily and housing markets. And now I'd like to switch to discussing homophily and labor markets. Yeah.
Yeah, a quick question on the previous slide, right? So the factor tau indicates the preference to either stay in a segregated market or not, right?
Yes.
Is there a way to also factor in, say, aspirations? Like, because I'm assuming some people might have aspirations to prefer this, but aspire to move somewhere else. But how would that?
Aspirations for what? For like living in, like I might have a utility function that specifies that I prefer integrated to segregated neighborhoods.
Right, or like a tau prime where I prefer a different segregated neighborhood than my own.
A different segregated neighborhood than my own. Okay, so the question is about changing the preferences of the individuals in this market, and you could imagine different ways to perturb the preferences. One of them might be that I like my preferences were very binary in the model, right? I either was happy or unhappy. And if I was unhappy, I was going to move. But you could have smoother utility function that says that I'm, like more or less happy depending on the composition of my neighborhood. And my ideal point might not even be at like, I might not always prefer more segregated neighborhoods. I might even prefer somewhat mixed neighborhoods. So this kind of thing has been looked at and gets similar results to this. I don't know I can maybe offline give you some citations to specific literature, or you could look online. The other question was, what if people just have an innate preference for certain neighborhoods? Maybe like, I want to live near, I don't know, the mountains because I like hiking. Then I think this would help. Again, I haven't seen this result studied, but intuitively, because I can now think about this mechanism that we've unveiled, this would help sort of stem that flow. Yes?
So here it looks like you're looking at similarity with respect to like one color, right?
Yeah.
One dimension. Is there anything like, what if there's like, you're okay with people similar in like one dimension out of many?
So the question was about the definition of homophily here. I'm assuming every individual has a single type, and that I am going to want to live in people that have types that are similar to mine. I live in neighborhoods with people that have types that are similar to mine. But what if types, I mean, we're all much more multidimensional than that. So what if types have some, that there's a vector of types, and every individual is a vector of types. I started talking about this with some people at Simons. I haven't seen research on that that I'm aware of, but like you could imagine that this might help like create integration, and now you have to think about also what your utility function is, because if I match on one dimension versus 2 dimensions, am I happier matching on 2? Or like, so there's some sort of modeling questions that you have to iron out there, but I do think that's an interesting direction. Yeah.
What happens if red and blue has different tau parameters?
Okay, that's a great question. The question was, what if red and blue have different tau parameters? This was actually studied by that Varpamalus group that I cited, and I can give you a reference to that. The sort of idea here is that there's some evidence that certain types are more tolerant of being a minority than other types, and in particular, maybe if they're already a minority in the population. So that paper looked at, what if we fix the 2 types to be 50-50, but we say one type is more tolerant than the other type. And then you can see that you get segregation in these settings if the tolerance parameters are in certain regimes. And I actually have a slide that I hid for sake of time that sort of plots this 2-dimensional space. But the only points on the diagonal, which is when we have the same taus that are known, are the ones I just presented to you. Yeah.
Can this process ever be periodic? Like, is changing their preferences simultaneously?
So the question is whether the process can be periodic. So with either the flip or swap dynamics, for the tau less than 1/2 regime, the process always converges, and there's a sort of potential function argument that you can use to show that. But for tau greater than 1/2, and this is one reason I said less about it, you can imagine that there's configurations that people are unhappy, but they just can't find anyone to swap with. And so I guess then it becomes a question of how do you model that? Like, do you let them swap with someone who's happy? Like, do you allow weak Pareto improvements? Then you might not get convergence. Yeah.
So it seems that this mechanism really relies on its beginning having exponentially distant homogeneous neighborhoods. But when you think how cities are grown, you start to live in a neighborhood which tends to be that. So you build housing, maybe build sort of the housing complex for mainly for the black people in the city. And you have another sort of suburban area where you put the white ones in. So originally we get very soon to white flight, but wouldn't you originally have sort of more adjacent
Yeah. So
homogeneous neighborhoods, and then what would happen?
So Christian is pointing out that my mechanism or my analysis relies heavily on the assumption that people are initially distributed uniformly. And indeed, if you like, so you could ask this, the question, I guess, is what if maybe a more realistic assumption in cities is that some areas are like immigrants come to New York City and they move into like, you know, the Lower East Side if they're Italian or whatever it is, right? And so like, if that's the case, then how do you think about what would happen, like what happens to this mechanism? And certainly if those ethnic enclaves are strong enough, they're not going to, they can then resist these waves of immigration. So I think the answer is it's going to depend on how you model this. One way to view this result is that like this ideal of full integration, if that's the ideal, is unsustainable without some sort of policies or mechanisms to stabilize it. I wanted to see if there's any questions on Zoom, so I don't know where to look to see you guys.
I'm looking.
But please ask questions on Zoom. I'd be happy to address them. Yeah.
What is the size of the buffer relative to?
Okay, yeah, so now we're getting into details of the proof, which is I asked there, right? That's what you're asking about. So like I said that I'm going to draw two circles. One is large enough, but not too large, such that I get exactly one of these guys that's going to like create a wave of immigration. And the other is a buffer, making sure nobody from the outside impacts me. And the ratio of the sizes of these is polynomial in W, but like I want to maybe stay away from the details of the math. I'd be happy to go through that with you offline if you're interested. I think in the interest of time, I might move on to my second. I'm happy to discuss this more in the Q&A after the talk. But I would like to get a chance to tell you about homophily and labor markets. And so this is now a different model, but I think it's interesting and part of this talk because it has one of those same drivers, which is homophily. And you might be looking at this and thinking, well, homophily you defined as being about social networks. What do labor markets have to do with social networks? And to answer that, I'll reference Frank Robinson, who was a baseball player, and he said, I've never seen baseball advertised for a job, and I've never heard of whites applying for a job. I mean, there's an old boy network and it's lily white. And so what's emphasized here is that, you know, jobs are acquired through networks, and in particular, this is going to be through referrals in my model, and that these networks, these referral networks, are very homophilous. So we get a lot of like in the baseball case, all the employed workers were white and they were all referring white people. And so that's anecdotal, of course, but there's a lot of research documenting that referrals are important for getting jobs. So there's a bunch of survey literature by sociologists showing that, so for example, TOPA in 2011 showed that over 50% of jobs are found through referrals, and this has been extended to labor markets of all different sorts of skill levels. And so it's true of call center employees, it's true of university presidents. And so referrals are important for getting jobs. You might like, you know, that this isn't a causal study, but there's this other study that I think is very beautiful. And if you're interested in reading some of the empirical work in this space, and this is a paper that looked at the random assignment of soldiers to units in World War I, and then studied the employment outcomes of the soldiers after the war. And what they found was that having been assigned randomly, remember, to a unit, this is because of the draft, having been assigned randomly to a unit where your peers ended up more employed, increased your own employment chances by 0.8%. And so that suggests that there's at least some kind of network effect, even if it's not referrals, there's some kind of network effect where having highly employed friends improves your chances of employment. So, okay, referral networks matter. then you might ask, what is the impact of referral networks, right? Referrals are a very sort of local thing again. What's the impact on the overall labor market in sort of global statistics perspective? And we'll see in the context of a model that I'll define for you that the impact of these referral networks is to, there's going to be inequality if workers with referrals end up being advantaged. So if the referrals are going mostly to the lily white old boys network, then you're going to get inequality in who you hire. There's also going to be immobility in that this inequality is perpetuated across generations. And surprisingly, I think referral networks are going to have an impact on productivity because referrals are actually good for the economy. Because what does a referral do? It lets the firm have an extra chance to screen a candidate before they make a hiring decision. And so we'll see that referrals are good for the economy, so they increase productivity, but referral networks with more equality are better at increasing productivity. And so that'll be the takeaway. So let me start by introducing the model. I have a set of firms and a set of workers. I'm going to assume that I have more workers than firms. So there's going to be some unemployment in this economy. The workers, again, are of two types. You can think about this as men and women or something. We have the blue circles and the green triangles. And those types are publicly observable, but otherwise the workers are ex-ante identical. The workers have values, of course, so each worker generates a potentially different value for the firm, but these values are not correlated with the types. In particular, the values are drawn from some IID, from some known distribution F. Okay, now the firms are going to hire workers from the population, and when they hire a worker, they generate some value, which the worker generates some value, which is equal to her quality as a worker, her VI. So then in the economy, I'm going to have a set of firms that have some employees and some unemployed people. And this is what's happening, say, currently today. But firms are long-lived and people are short-lived. So all these guys are going to retire and the unemployed ones are going to die poor and hungry. And so the firms need new workers for the next generation. And so we assume that there's some next period employees, next period workers, and the firms want to hire from these next period workers to continue their business. So how do they hire? Well, they can hire from referrals. In a referral, each current employee is going to refer a next period worker. Let's assume for a moment that the firms have exactly one employee and each employee refers exactly one next period worker. And the network, the friend network here is that all blues are friends with each other and all greens are friends with each other. And so the blues are going to pick a person at random from among the blues to refer, and the greens pick a person at random from among the greens to refer, generating some referral network that looks something like this. This can be relaxed to more interesting social networks, and much of what I say will go through, but this is easier to think about. So this is how the firms get referrals. And now what is the value of a referral? Well, it gives the firm a chance to hire, an extra chance to hire. So the strategic decision of the firm now is to decide whether to hire the referred worker or hire a random worker that's pulled from the pool of unemployed people, right? And what's valuable about referred workers, we're going to assume that there is a screening effect here. That is, that this firm, when they get a referral, they're also told the value of that worker, right? So they get to see the value of the worker that they're referred to before they make an offer. Whereas if they hire from the pool of unemployed workers, they don't see the value. They have to hire the person, employ them for a while until they learn the value. This is, perhaps an extreme assumption, but it's well documented that firms have more information about referrals, and that's why employees hired through referrals tend to be more productive than those hired on the open market. And so we've just taken this assumption to the extreme, but you could imagine relaxing that. So in order to understand this, now I'd like to discuss what are firms, how are they going to hire? Like they have a choice to make here. Do I hire my referred worker or do I go to this unemployed pool? And in order to understand that, we have to think through what's called the Lemons effect in job markets and labor markets. So you've probably, if you've ever tried to buy a used car, you've probably heard about lemons. They're like the cars that don't work as well as you were promised, and there's lemon laws and whatnot. So that there's lemons in many markets. In the context of labor markets, lemons were first explored by Montgomery in 1991 in a model different than ours, but somewhat similar. And then a lot of empirical economists and sociologists have gone on to document that this effect exists in labor markets. So what is the lemon effect? It's the idea that if a firm has a referred worker, then they might look at that person, see their value, and decide not to hire them. Why would they decide not to hire them? They would not hire them because their value is low, right? And so if a firm looks at a next period worker, decides not to hire her because her value is low, what happens to that worker? She's going to enter the pool of unemployed and wait for a random to be that lucky person that's picked from the pool of unemployed and get hired by the next firm. And so this worker, we call her a lemon, because when she enters this pool of unemployed workers, the effect that she has is to pull down the average value of unemployed workers. So the lemons effect here is that the average value of unemployed workers in the pool is smaller than the average value of workers in the population overall. Okay. And this is key to understanding the equilibrium, because what the firm has two choices. I can hire the referred worker or I can hire from the pool. And clearly I want to hire the referred worker if they're better than the average value in the pool. So that's going to be the equilibrium. The firms are going to hire the referred worker if they're better than the average value in the pool. And now the average value in the pool is in fact the solution to some fixed point equation, because this is endogenous based on the threshold, these strategies of the firms, which can be characterized by this threshold. And so you can solve some fixed point equation to understand what this looks like. It's not that important. The point is that there's some endogenous hiring threshold, and firms are going to hire the referred worker if they pass that threshold. Otherwise, if they don't pass that threshold, they throw them back in the pool, which is the right choice for that individual firm, but then imposes an externality on the market as a whole, because other firms might now hire that limit. And so they could also potentially fail to hire if they all go after the same worker. And then there's a competition for that worker, and that worker ends up in the pool. I mean, that firm ends up hiring from the pool as well. And so you can already see that there's this inequality in the labor market, the fact that even though 50% of the population is circles, but 2/3 of them are employed, is going to lead to inequality in the future period. And that's because if there's an uncharacteristically large portion of blue employees, then there's going to be an uncharacteristically large fraction of referrals to blue next period workers because of the homophily in the referral network. And so because referred workers get more offers on average, it means that the next period is also going to have more blue workers than green workers. Now, if you're listening closely, you'll say, but wait a minute, the pool is going to, if there's 50-50 in the population overall. So if more blues are hired on the referral market, there will be more greens in the pool. So that when you pull at random from the pool, you're more likely to hire a minority, or according to employment, the disadvantaged group. And so that causes this inequality to attenuate over time. What is interesting is that this inequality could perpetuate indefinitely if you have other sort of tweaks to the model that seem very realistic, like maybe you need to invest in education in order to attain your value as a worker. And then if Greens wake up and realize that they're not going to get very many referrals because there's a too few Greens in the employment market, they might find it not valuable to invest, and then this could cause the inequality to perpetuate over time. Yes?
You're not better hiring off the green workers?
So the question is if you're better hiring green workers. So we are assuming that the firms are myopic, or maybe there's laws that discourage me from picking types. The reason that green workers are actually good for a firm better than just their value is that they have downstream value, right? Because hiring a green worker means that I'm less likely to encounter competition for a referral in the future. Is that what you were thinking about?
No, less likely to be lemon.
Oh, okay. So that's about hiring green workers on the referral market. And I'm assuming that away because I'm assuming firms are myopic. I'm only trying to optimize my next period utility. But there's also a thing about the unemployed pool, which is that, and this is something that I think is actually pretty nice too, which is that in the unemployed pool, the Greens are less likely to be lemons because they had less referrals. So in fact, the minority type in the unemployed pool is actually more productive than the majority type. You would rather hire the minority type in this model than the majority type. I'm assuming that search in the pool is very expensive, and so you just get your one draw and you can't draw again. But indeed, if you could, and this would further attenuate this problem, you would prefer to hire the minority type because they're more likely to have a high value. And by the way, on the flip side, the employed blues are more likely to have a high value. So if you do some bad economics and you say you can conclude that blues are you only study the productivity of hired people, you could accidentally infer that the majority type is more productive, even though that's not true in the model. So anyway, this is all about inequality. There's lots of interesting nuances here, but the one that interested me perhaps the most is this idea that inequality in this model actually also drives inefficiency in the market overall. So why is that? You can look at two different networks. Here's the more equal one on the top and the more unequal one on the top and the less unequal one on the bottom. So here we have blues are 50% of the population, but hold 2/3 of the jobs. Here the blues are 50% of the population and hold 50% of the jobs. What's the impact on the referral network? Here you have 50% of the referrals are being distributed, 2/3 of the referrals are being distributed to only 50% of the population among the blues, and 1/3 of the referrals are being distributed to the other 50% of the population. And so as a result, you're going to have more people with multiple referrals up here, and simultaneously more people with no referrals when the network is more unequal. So what's that imply for the economy? Well, remember, referrals offer this sort of screening effect because you can look at the value of the employee before you hire them. And so when we have more inequality, there's more people that aren't screened because they never got a referral to begin with. So that's one effect. But also simultaneously, a lot of these people that weren't looked at had high value. They ended up in the pool and they dragged the value of the pool up, thereby lessening the lemons effect, making the average value of the unemployed people closer to the value of the population overall. And this first effect is bad for productivity, right? Firms, if they're screening less, they're less likely to catch those high valued workers. Whereas the second effect here is good for productivity. That's because this externality that me rejecting somebody of low value, that there's less of that, right? When I hire at random from the pool, I'm more likely to get a good worker. And so what we were able to prove is that the first effect always dominates the second, and hence employment ratios that are closer to being population balanced strictly improve productivity. So what could we do about this? And in this case, I did try to study a particular policy. In particular, I wanted to look at affirmative action as a way to address this productivity hit and inequality in the social networks. And there's many ways you can imagine implementing affirmative action. I know that this is kind of like a word from the 90s, but I think it still exists a lot today. Scandinavian countries require 40% of their board members to be women of publicly traded companies, which I think is amazing. Colleges often have scholarships for minorities, grad students. So we're basically subsidizing the minority type, the hiring of the minority type. We could also potentially require firms to interview more broadly, and this would require me to be able to make decisions based on type, but I could, if I'm able to do that, I could require firms to interview the minority type. This happens at Microsoft. We're required to have a diverse slate for any position above a certain hiring level. And so that gets at least the foot in the door for these greens. And so on. But basically the overall impact of any of these is to increase green employment. So yeah.
If I understood the mechanism, so one other thing that you could do is insist that you refer people of each type.
So Sid is asking if I couldn't like just break the homophily. I could insist that you are only allowed to give me a referral of the other type. I'm taking in this talk homophily as a kind of fact about the world that I'm not able to manipulate. You just don't have friends of the other type. I'm not going to have time, but I have a comment that I prepared that I probably won't get to about why, even if there's no racism or hatred in society, there's actually a rational reason for us to exhibit homophilous preferences. And so I'm taking that as fixed, but certainly that could be one thing. And that's actually something I would love to suggest to LinkedIn, which is that they create a lot of these like mentorship programs that cross racial boundaries. So how do we think about the impact of increasing green employment? You might say, well, of course, if you increase green employment, that's got to be good for greens, right? In the next generation. So I increase green employment in the current period. What impact does it have on the next period? And in fact, you can cook up examples where there could actually be a perverse effect. And this is driven again by that lemons thing I was talking about. So here, you could imagine that you start with a very unequal population, maybe 0.3 employees are green, and you consider increasing them. As you increase the current green employment, you have to think about what happens to where people are being hired from, because remember, the referral market is disproportionately blue and the pool is disproportionately green. And at very unequal employment rates, there's not so much hiring happening on the referral market because, I mean, there aren't that many referrals to start with. So there's a bunch of hiring happening in the pool. But as we increase the mass of green workers that are employed, we get more hiring. We change the hiring threshold because we get more lemons, right? So we have more referrals, we get more lemons. And so the quality of the pool decreases and it could suddenly jump and or like suddenly drop the quality of the pool, causing the hiring on the referral market to jump when we get near these boundaries. In this example, we have a lot of mass on a value of one type, and that's why this jump happens. But you could do this with continuous values as well. And so as a result, you might get that the next period employment, that because, you know, all of a sudden, when you increased green employment in the current economy, the next period employment was basically all drawn from the referral market where blues are favored. This could harm the next generation. So this is a thing to be wary of, but in fact, we can show that affirmative action, if it doesn't sort of jump over those cliffs, is going to basically always work. And if it's moderate enough, it's going to in fact always improve total production in all future periods. So it's not only good for equality, for speeding up this convergence to equal labor markets, but it's also good for productivity. And so to recap, what we've learned in this section of the talk is that homophily in referral networks can cause labor markets to perpetuate inequality and reduce productivity. So this might be a thing that we want to address. Again, the reason I care about doing the theory is because I feel like doing the theory illuminates mechanisms that drive the theoretical result that we can then try to address with policy. And so the mechanism that we had here was this concentration in who gets referrals. That inequality causes a concentration who gets referrals. And what we really want to do is spread out the referrals evenly around the population. And Sid suggested one way to do this is to get people to refer people of the other type. Another way to do this is with affirmative action. You could imagine, and we explore in the paper, other ways to also increase inequality, like having more flexible firing policies, or another, I think, interesting one for this crowd is that if you have an online market like LinkedIn, you could imagine creating policies around the search in the pool. So someone also brought this up, that like I think Ilan said you'd rather get greens from the pool. In fact, what you want is to get people that were not already rejected. So you could imagine some kind of algorithm implemented in online labor markets that tries to give everybody a chance, right? Like you give when somebody asks for a draw for an employee, you try to pick people that haven't yet been looked at. So I had hoped to tell you about rational explanations for homophily. I'm not going to get to this because of time, but I would just want to point out that I've taken throughout this talk homophily as a fact of existence, of human existence. And certainly there are a lot of explanations that are things that we should try to address about behavioral norms around racism and hatred and these sorts of things. But I think that homophily will always be with us because there are some, in fact, rational explanations for homophily. Namely, if I talk to people that are more similar to me, I get more information about the truth, the underlying truth. And so this is based on joint work with Divya and Nika, who are here, and Shuchi, Brendan, who will visit. And so yeah, if you want to hear more about this, ask one of us. But in the interest of time, I will skip to the conclusion where I want to point out that I discussed how homophily exists. The fact that homophily, I defined what homophily was, this tendency for humans to seek out those that are similar to them, took it as a fact that this exists, and pointed out that this has profound impacts on society, even though it feels like a very local personal thing. It can have global consequences, both in, we explored in this talk, homophily and geographical segregation in housing markets, and also its impact on inequality and mobility and productivity in labor markets. And sort of another zooming out, this is an Institute for Theoretical Computer Science, and I think it's very important to continue to pursue theoretical results about social systems. And why is that? Because I believe that theoretical work will shed lights on the mechanisms at play in these social systems and thereby allow us to address, design policies to address them. Thank you.
Online use is fine, but maybe there's a couple more questions here. Sounds very hot.
Thanks for a really nice talk. I had a question about the first half about the housing. One theoretical, one practical. The theoretical is the sorts of the kind of like the sort of behavior in the subcritical case, where you kind of have these like things spreading. Reminds me at a very vague level of other dynamical systems, things like sandpile models. Are there other dynamical systems that you know that behave in similar ways? And I mean only at a very squishy level. That might be a even simpler version of what's happening.
Yeah, so the question was whether there are other dynamical systems that exhibit these kinds of models where some phenomena spreads virally throughout the system. And I guess you could kind of consider certain information policies and social networks to have this type of property. Of course, now it depends very much on how you define the dynamical system, but how does news become viral? Would be you could set up models in which you could explain the virality of certain types of news, and it would have this sort of feature that it just swarms out the other stuff existing in the system. We also saw this a little bit in the boot camp when Amin Saveri presented his work on that was based on the work of Morris on how products spread, how like adoption of products spread, and so some product can become viral if people want to adopt it when the majority of their neighbors have adopted it. So yeah, I can point you to some other systems that do this, but it is an interesting phenomenon. I don't know anything about sand files.
Barely even do I. So, and then on the more practical side, is there data that suggests that this sort of spread happens in practice?
So yeah, then the question was, do we see this sort of segregation in cities in practice? And I think so people have tried to fit these models to segregation in like Chicago. I think Marcus Mobius, who's a co-author of mine on one of the later papers, was in his job market paper, was looking at these models to help explain segregation in Chicago, where you see things like white flight, as people like to call it. But yeah, there's a whole nother interesting piece of all of this, which is we should believe that this is at play in practice if we want to start trying to address it. And I think there's evidence to that.
There's a lot I don't understand about modeling, but I wanted to ask them about the number tau in the first half. Isn't it clear that it wouldn't be just one number, that there'd be a distribution, tau would be a distribution, and that not only would there be a distribution, but there might be some generalizations to be made about how green circles and blue triangles might have a different distribution for tau, and that would affect the segregation behavior.
So the question was about the tolerance of individuals in the housing market section. And if individuals have different tolerances, some are more tolerant than others, could this impact the outcomes? So there's one aspect of this is, what if there's, it's not correlated with type, but some people might be happier with more integrated neighborhoods than others. And for that, I think you can see from sort of the intuitions I gave that so long as most of the people still fall in this, what I was calling subcritical regime, the same kind of dynamics will persist. But the other elements of the question was, what if it is correlated with type and maybe blue circles are more tolerant than green triangles? Then there has been some work on this showing that you can get complete takeover by the less tolerant type.
So I have two questions. The first question is, shedding segregation seems to be studying spatial segregation. Are there models or papers studying temporal segregation in the sense that if in the same location, there are certain hours of the day the Black population is hanging out there more. There are certain hours of the day that white population is hanging out there. I live in Chicago, so in our apartment complex, there are certain days you see white folks are at the pool, and then there are certain days that you see.
So the question was about temporal segregation. I don't quite see the mathematical distinction in that. It might change the network structure, but I should be able to map each hour of the day to a location in a network where there's a clique on the hours that assume everybody spends half a day at the pool. There's a clique on the hours that are within half a day of each other. And so I would try to address this question doing something like that. So then the question would translate to Are there, like, I think for hours in a day, you could even look at it as a line or ring if you like. But a more general question that I think you're asking implicitly is, what about other networks? I just looked at 1 and 2D lattices, higher 3D lattices have been studied. But more general networks, I'm not aware of a lot of work that looks at generic underlying network structures. I think in part because you have to come up with a story as to why you care about that network structure, and notice that there's something that we're trading here in the sense that I'm moving out of my house and you move into my house and thereby inherit the neighbors that I had before, right? So that dynamic has to be motivated in whatever you're thinking about, as well as the network structure.
Thanks. And then my second question is about the second part of the talk. So when you think about referrals, they seem to be sent out simultaneously. But in reality, there's this notion of times, for example, if I want to refer someone, I can ask that person whether he or she has been already referred by someone else. If yes, I'm going to pick someone else from that random among the people that are in my network. Does that fix the referral concentration?
So the question was about the timing of referrals and the timing of hiring. Of course, hiring is in many, not all, but many labor markets, it's somewhat continuous over time. And so you could imagine, like, I might not wake up and when I wake up to refer somebody, the one I was going to refer to has already made an offer, I can move on to refer someone else. This is not something I've thought about before, but I think that if you have this complete homophily and you have a lot of blue employment, it's just going to cause, it won't fix the problem, because you're going to get still all the blues are going to be getting like half the population, blue half is going to get 2/3 of the referrals in the model presenting. So there are, I think, things that continuous hiring might change, in particular that weird sort of hooked up counterexample to affirmative action relied on the timing of the hiring being kind of simultaneous, but I don't think it'll fix the main problem that I was interested in.
All right, so we're going to take one more question, and this will be the one online question that we have. So do you think that homophily has a negative impact on academic and scholarly networks insofar as it may lead to the formation of closed groups of scientists that are less open to free exchange of ideas and the pursuit of novel avenues of research?
Great. So is there a name?
Sergio Gallos.
Okay, so Sergio Gallos is asking online if homophily in academic networks is problematic for science, I guess, as a summary of the question. I think that there could be a lot of issues with, so I think homophily, okay, so this is actually a good question, because we sort of think of segregation in cities, for example, as being bad. But I don't think that homophily or segregation is inherently bad. I think that it's nice to be in a place where you feel welcomed and like a part of a thing. I think what's bad is if you don't have these sort of bridge types. And so I think academia definitely suffers from this. Like how many Trump supporters do you know in your departments, right? And like by eliminating that or suppressing that element, I think we're losing a lot of diversity of ideas. And we suppress that element so extremely in academia that we don't even really have relationships with these people to acquire their ideas. And so I do see this as being problematic.
Thank you, Nicole. Continue the discussion in the cooler location.